Hi, in this video we'll learn how to build a RAG, a Retrieval Augmented Generation web application using Python, Streamlit and LangChain. We'll learn how to do all of this step by step, so you will be able to add your custom documents and also the content of websites to the context of your conversation with the LLM, so it will know all this information that otherwise it won't know. And we will see how to do this step by step. We will learn how to create a website with it using Streamlit and how to deploy this website for free into the Streamlit cloud. But in the next video, we'll see how to deploy this website into the Azure cloud using single sign-on authentication to make sure that only authenticated users can access to the application. So make sure to subscribe to this channel if you want to see this content and the future videos that we'll be doing. So this is the website online that we'll be building today, and as a quick example, if we don't use RAG, if we deactivate the RAG and we ask what is the latest version of Streamlit, it will tell us that the latest that GPT-4o knows, it's the 126 because GPT-4o was trained until October 2023. So now if we activate RAG and we clear the chat to not contaminate the conversation, and we ask what is the latest version of Streamlit, now that we have in the RAG the changelog of Streamlit, now it knows that the latest version as of today is the 1.38. So because we send here as the context the changelog information of Streamlit as an example, so we send all of this information of this website to the RAG context, and now it knows about this. So this is the website that we will be building in today's video, and it's able to chat with GPT-4o, and if we add here the Anthropic API key, we can also chat with Claude 3.5 Sonnet. So now we can also do RAG with Claude instead of GPT-4o. Let's ask what are the main features of the latest version of Streamlit. And now Claude is telling us all the new features that it saw from the context. So let's go. Let's see what is RAG and how to program a RAG application. Okay, so what is RAG? In order to understand what is Retrieval Augmented Generation, first of all, we need to understand that LLMs are trained with large amounts of public data up to a certain date. So if we need an LLM for a use case that has to know about our own private data or newer data up to date or about a very niche topic, then we will need to provide this specific information to the LLM, and this is what RAG allows to do. RAG allows to get our own specific data and do in-context learning, introduce this data into the context together with our question, so the LLM can answer so much better and precisely to our question with this very specific data in the context. So RAG consists in two phases. The first phase has 4 steps. First of all, we load the data, so we load the documents. Load means to extract the raw text from PDF, from PPTs, Word documents, also from websites. We'll learn how to do all of this today. So then the second step is to split these documents into chunks, because probably we'll have a very large amount of data that they don't fit all together into the context, and maybe not all the data is relevant for every question. So we'll split this data into chunks with a certain amount of characters with some overlapping between them to not cut any context in half. The third step is tokenizing or embedding these chunks of data. So we need to transform from text to embeddings, these vectors. That is how internally the LLM makes sense of the words. So it doesn't understand words per se, but it transforms every token, every word or part of word into these vectors, and in this vector space every word has its meaning. So every space in this 1000-dimensional space has its own place. For example, cat and dog are close because are animals, but maybe house is farther from them. So there is this 1000-dimensional space, and we will put our chunks of data in it. So we will transform it into embeddings, and then whenever we have these tokens of our chunks of data, we will load them into our vector store, our vector database. So here we have the vector stores that are usable in LangChain. We'll use ChromaDB, that is one of the more popular ones, and it allows us to make our own vector DB in our system locally. So this was the first phase, the indexing phase, and now that we have our data, our custom data into the vector store, now we can do the second phase, which is the retrieval and generation. So in the retrieval and generation phase, we have 2 steps. The first one is retrieval. For a given question or for the context of our conversation, we'll transform this conversation into tokens, and we'll compare these tokens, these embeddings, to our vector store, and we'll get the chunk of data that we loaded into a vector store. So we'll compare the distance between our question and the chunks in the vector store, and we'll get these chunks that are closer to our question. So we'll be retrieving n chunks of text, for example 4 or 10, we can decide this, And we'll add into our conversation, into our question, in the context, we'll add these more relevant chunks of text for the LLM to know better how to answer our question. And finally, we'll do the augmented generation, which is generate the normal LLM response, but with this augmented retrieval data into the context of it, so it will know better how to answer our specific question. So these are the 6 steps in 2 phases of Retrieval Augmented Generation. Okay, and why not doing fine-tuning? So first of all, fine-tuning means to get an LLM and we can either train it from scratch, which is very, very expensive, because nowadays the best LLMs are trained with trillions and trillions of words, with basically all the data available in the internet, with many, many days and even months of GPU computation. So it's almost impossible to train from scratch a good LLM. But even so, you can fine-tune, so you can get a train one and finish to fine-tune with sending it your custom data, but you need to do it with some thousands at least of examples, and even so you can only do it with an LLM that it's available, so an open source one and probably not one of the largest one, and then you need to maintain this model and serve it. So this takes time and more money, and also it won't out of date. So if tomorrow Meta releases the Llama 4, for example, you will need to retrain from scratch this new model. And also there is finally another thing that happens when you do fine-tuning, that is catastrophic forgetting. And this means that when you introduce new data to an already trained model, what can happen is that some of the weights that you are manipulating, some of the previous weights that were there in the model, change slightly and it learns about your data, but it loses some of the previous information. So this is also a caveat that can happen when you fine-tune a model. And finally, another thing that happens when you do fine-tuning is that whenever you ask something to the LLM, it cannot tell you where it learned it from. So the LLMs cannot tell you the references or the sources of the data or the information that it's providing you. Maybe sometimes they can respond you, but most of the time will be hallucinations. They don't know for sure where the data comes from. So this is also another thing that RAG can do. So when you do RAG, you know every chunk of text, what is the metadata of it, and you can know what website or what document they come from. So for all of these reasons, RAG is easier and faster to implement. In general, it's better to start doing RAG for 90+% of the use cases. And if RAG doesn't work properly and you have the money, the time, the resources to do fine-tuning, then you can think about doing fine-tuning. Okay, so let's see how to do it in code, and we'll be programming a RAG application using Streamlit and LangChain. But first of all, let's create a notebook to understand better the RAG methods step by step, and then we'll be integrating them into the web application. So let's start by creating here our project folder. I call it RAG LLM app. And here in our project folder, we have to open the terminal, go to the project folder here in the terminal as well. And here we can create the virtual environment, first of all, if you want. This is optional, but a very good recommendation. Now we can activate, and now that we have the virtual environment activated, we have to install these libraries of here with pip. Let's see them. You can see all of this code in my GitHub repository that I left the link in the description, or also in the blog that is also in the description, and you can copy and paste it from there. So let's install this. Okay, now the next step is to create our .env file where we will be putting the OpenAI API key and the Anthropic API key. So the OpenAI one is mandatory because Anthropic doesn't have embedding models, so we'll need to use the embedding models from OpenAI anyway. But if you want to use Claude to do the retrieval augmented generation, we can put here as well the Anthropic key. So you can use only OpenAI or both of them. And here you have to put the API key of one and the API key of the other one. And make sure to not share this with anyone. Okay, now that we have our API keys, let's create the .gitignore. And here, if we put virtual environment, but also env, we make sure that our API keys doesn't get pushed to GitHub, so we don't share our API keys whenever we push these into GitHub. And now let's create the notebook to try the RAG methods with LangChain, and I will call it RAG LangChain IPyNV, and we'll start selecting the kernel here, virtual environment, this one, not the normal Python environment. And here I will be importing all of these libraries, the ones that we'll be using today. And here we'll be loading the environment variables that we have here in .env. So let's run this. Okay, it ran, and yeah, it says this, but this is not a problem. So in the next cell, we will copy this code of here. And here we will start by doing the first step of the retrieval augmented generation that we mentioned before. So we will start by loading our own documents. And I will create here this docs folder to load some test documents. In here we will put this test_rag.pdf and this test_rag.docx. So you can create here the docs folder and put here your own documents. I will put them now. We'll put them here one by one. We'll create the path of every one of these files. And here we are checking what is the extension of every one of these files. So depending on the file type, we will be using a different loader, and whatever is the loader, we'll be using the load method that all of them have. And we'll extend this docs here, that is the list of the documents, but in the LangChain format with the raw text into it with its metadata. So we'll be extending this docs list with every one of these prepared documents to be embedded. And here we can remove the original document if you want. We'll do this later in the website, but here in this experiment is not needed. And here we have another method to load websites. So here I put this URL as an example. This is from the Streamlit release notes, the changelog documentation of Streamlit. So we'll be testing it with this one. And here we'll be sending with the web-based loader this URL, and this will extract the raw HTML text from it. And it will load this text as well in the docs, extending it as well in the similar way as before. And if it fails, we'll throw also an error. So let's try to do this. First, I will load the example documents. So in Word, I will create this random text to make sure that it's been loaded and we don't have any problem. But if it works with these two sentences, it will work for larger amounts of text. So let's save this now. Okay, so I already created these two example documents in Word and saving it as PDF. It has the same content, but it's only for this example. And also we have here the URL of Streamlit. So let's load, first of all, the two documents and then the URL. Let's run this and let's see if it's loaded. Okay, there was a small error before. I had here docfile.name, and yeah, as it is here now as a string, it doesn't have the name. It's only like this. So let's make it run again. And now apparently it's good. Okay, so we are loading these two files and also the content of the URL. So now if we go here in Excel and we do docs, we see, yeah, a list of 3 elements, and everyone is a document with its metadata. So the source and the content. Here you can see the content that I put in these two files. So let's see if when we ask these things to the LLM, it knows out this very random and specific information. And also here we can see the content of the Streamlit website. So let's go to the next step, and it is splitting. So we have to split these documents, and we'll do it with the recursive character text splitter from LangChain. This is basically taking all the text content, and every 5,000 characters, it splits it, and it gives an overlap between chunks of 1,000 characters to not split the context in half. So for the first 2 of them, it won't split because they have a very short content. But maybe in the Streamlit website content, if it has more than 5,000 characters, it will split it in different chunks that will be different documents. So let's do this. Let's split it. And now the next step is to embed, to tokenize this text and to load it into the vector store, into the ChromaDB vector store. And this is very simple done with this chroma method that we are importing from LangChain. And we are telling to create this new ChromaDB vector store from the documents. And the documents are these document chunks of here, the splits that we just did here. And we will be using the OpenAI embeddings, even if we use Claude with Anthropic. So here, let's run this again. It worked. We have here our vector store in this variable here. So now we completed the first indexing phase of our application. So now we have all our custom data into our vector store. Now we can do the retrieval and the generation methods. So let's go for them. Here we will start creating a method that will get the needed chunks from the vector store based on the conversation. There are some methods a little bit more simpler, but here it gets from all the history, not from the last question from the user, but from all the conversation. It gets the most relevant chunks of text from the vector store. So here we have to create the retriever from the vector DB as retriever. Here we have to put a prompt that it's telling the instructions. So here is the message placeholder for all the previous messages. Here is the last user input, so the last question. And here the instructions for the LLM that it's going to retrieve the data from the vector store. So given the above conversation, generate a search query to look up in order to get information relevant to the conversation, focusing on the most recent messages. So we are using an LLM in between here to generate a search query to go to look the most relevant information. So it's a little bit more advanced than some others. So here we are creating this history aware retriever. And this will be used in the next step, we'll see. So this is a method to do this first step, but to get the question then, the augmented generation answer from the model, we'll create this other method, this get conversational RAG chain. This will create the RAG chain using this previous step. And here we use the previous method that we created here, where we also send the VectorDB and the LLM, the stream LLM that we'll be using. And here we are telling the instructions to our LLM that will be answering using the context. So this context of here is all the document chunks that we are retrieving from the vector store. And here we have all the previous messages and also the user input. So with all of this is that the LLM will generate the augmented generation response. This staff document chain will be doing all of these steps automatically, and we only have to interact with the LLM. So let's now use these two methods to finally get these responses from the model. And here in the next cell, we are creating the Chat OpenAI LLM, but also the Anthropic one if you want to use also Anthropic. If you don't want to use Anthropic or you don't have the API key, you can delete this line of here. Here we are selecting which of them to use because we have to use one or the other. So here I'm using for now the OpenAI one. So this is our streaming LLM. We could use this without streaming, but with streaming, it will be even better because we'll be generating the response while it's created. We don't have to wait some seconds to get all of it. And also, whenever we have O1 preview or mini available, I don't have it yet. Here, instead of putting GPT-4o, we can put O1 or O1 mini in theory, and it will work with the newer models from OpenAI. But unfortunately, they are not yet available for most of the API users, only for the tier 5 ones. For now, we cannot yet use it, but whenever it's available for everyone, this is how we'll be doing it. And here I'm creating an initial conversation, and here we are doing the real question. This is the one that we'll see if it can answer from the RAG information that we introduce. Now here we transform the message history to the format of LangChain with human message and AI message classes. And now we are creating the conversational RAG chain. And now here, as we saw in the previous videos, how to do the streaming of the responses. So we get from the conversational RAG chain to pick the answer in streaming of all the messages and with the input. And the response will be produced in streaming chunk by chunk, and it will be printed, but also we'll get all the full response in the end, and we'll be appending the full response in here. So let's run this and let's check that we have to run this and this first, the previous two cells that we created here. And now let's run the generation of the response. Okay, we can see that it's been very quickly, but generated step by step. And it says that the latest version of Streamlit is 1.38, that it was released in August 27th of 2024. So it's impossible that GPT-4o knew about this because GPT-4o has been trained until October 2023. So it couldn't know about this, but as we introduce this custom information, it knows about it. So let's check this. Streamlit changelog, this is the website that we send as an example. So here we can check the last version of Streamlit is the 1.38 as today. So we basically get all the data from this URL of here, and we pass all of this information to the LLM. So now this LLM, while it's doing this conversation, it knows about all of these details of Streamlit with the latest versions of it. But whenever we reset the conversation and it loses the RAG context, it will lose this information. So the model is not learning this forever. It's only while it's keeping the conversation in the context of it. Yeah, really helpful, and it's really working. And now that we understand how RAG works and how to do it with Python, let's introduce this workflow into a Streamlit web application so we can have this in the web and we can upload any kind of document, load any content from any website and use it whenever we want online and share it with anyone, with any user that will be able to upload their documents, point to any website and do a RAG conversation with this custom information. So first of all, here in our folder, let's create a new file called app.py. But also we'll need to create here the RAG methods file. Here we'll be putting apart all the RAG functions, these methods that we have been testing in the notebook, but they will be slightly different up to the Streamlit application, very similarly, but with some modifications. So let's start with the app.py. So let's create a basic LLM chat application. So let's start importing all of this. Also, we have to load the environment variables. We'll declare here the available models. Here I commented the OpenAI O1 because it's not working for me yet, but whenever this works, O1, O1 mini preview, we can put them here. So we tell here OpenAI / and the model name, and the same for Anthropic. And like this, we'll know which method to use. Now the next step will be to put the title of our website. I will call it the title like, do your LLM even RAG, bro? As a joke. And here for the initial setup, we need to create the session ID, the RAG sources, and the messages for the website. So if this is not in the session state, we need to create these variables to make the website work. Okay, now with what we have here, let's see if this runs. So let's start by opening the terminal and activating the virtual environment. We already installed all the libraries before, and now we can do Streamlit run app.py. And yeah, it's working. So we have only the title so far. Like this, you can check that the basic setup is working. Okay, now we'll need to add to the users their API keys, because if we do this later online, we don't want to use our own API keys for everyone publicly. They can spend a lot of money for us. So in a similar way as we did in the OmniChat, the previous application that we developed in the previous videos, we ask here the full API key. If we are in our local environment, we are getting it from the environment variables. But if we are in the cloud, we don't put there our API keys in the environment variables. So if the API key is not in the environment variables, it's asking it to the user. Let's save this and let's check if it's working. Always rerun. And here now in the sidebar, we have the OpenAI API key input and the Anthropic API key input. Now we'll put here these messages. So if there is not the OpenAI API key or the Anthropic API key, we'll ask the user to input before continuing. And now if there is any API key, we'll let the users to select which model they want to use from the list of available ones, this list that we declared before. For now, we'll create here these columns and we'll only put here a button to clear the chat in the right one. Later we'll see another option when we introduce RAG, but let's do now a basic LLM chat. And now let's create here the main part of the chat application, and we'll start by detecting what model provider is the user inputting, because if you remember, every model name is the provider / and the model name. So we are dividing here by the / and getting the first part, and we'll detect if it's OpenAI or Anthropic. Like this, we'll choose the chat OpenAI from LangChain or the chat Anthropic. And in the same way, so from session state, the model split by /, here we detect the provider, and with this part of here, we're detecting the model name. That is the second part or the last one. So the model name will be the second part. Temperature here is fixed to 0.3, but you can change this or you can allow the user to move this. I will put it fixed to 0.3 for simplicity, and streaming to true to have the streaming capabilities. And this will be our LLM stream model. Now, if we already have some messages in the history message, in the session state messages, we'll be displaying them like this in the Streamlit page. For now, it will be empty, so there won't be any messages. And now, finally, if there is a prompt, so here we'll be introducing this chat input Streamlit component to get the user's input. So if there is a prompt from the user, let's append this to the chat conversation. Let's print it here in the UI, and let's use this prompt from the user that will be now the last message in the messages history. And let's use it to get the LLM response. So now we need to define this stream LLM response function. I will save for now the app.py, and in RAG methods, we'll start declaring this first method. And this is the stream LLM response function. And we need to import Streamlit, and for now that's all. So this is the typical function that we already saw in the last videos, that if we have an LLM in streaming, this is how we can get every chunk of text yielded from this function, but also the full response message at the end, and we are appending it to our messages in the session state as the role assistant. So every new response from the model, we are getting it in real time in streaming with this yield, but also we get the total response in the session state messages history. So we have to do it like this. So we save now this stream-learn response, and now here in top of the app.py, you have to import it. So from RAG methods, import stream-learn response. Okay, so now I think that this is all for now to have a basic LLM chat application. Let's save this and let's test if it's working. So we can see, okay, the clear chat should be in here. But apart from this, let's see if it's working with GPT-4o. So let's say hi. And yeah, we got the response from the model. It's so short that we haven't seen the streaming of it, but let's put tell me a long story. And we see that it's generating the response in streaming, so we don't have to wait for the entirety of it to be displayed here. So it's working. For now, we have a basic stream LLM chatbot. Now let's add the RAG into it. Let's combine these two things that we've seen today. So let's go to the code and let's fix the clear chat history button. It's here, the clear chat, and the problem is that these two are missing one tab. So now all of this is inside the ST sidebar and the clear chat will be in its place. Now it's here. Okay. So if we do clear chat, it's deleting all the conversation. Okay, that's also working. So now here in ragmethods.py, we'll introduce all of these methods that we have been developing here in the notebook. So let's start by introducing all of these imports that we need. Let's do it quickly here. So we need all of these, os.env, time, streamlit, and all the LangChain methods that we have been using before. So it's pretty much the same. Now we have this stream-LLM response that we just defined. We have to keep it. And we'll need here db docs limit. This is a constant. So how many documents we allow to the users to introduce. And we'll do this because otherwise some users can introduce like thousands of documents. And as we are storing this in the ChromaDB in memory, so our vector store is in memory for now, we don't persist it in the disk. This can make the memory to overflow. You can put here 50 maybe or more than 10, but let's put here some limit. Now let's do the load method. As we saw before, it's similar, but it has some additions because now we are in Streamlit. So this is how I'm calling the load method. And let's put here indexing phase. So the first 4 steps that we saw before. So first of all, we have to load the docs to the vector.db. And yeah, we have to check if we have this session state RAG docs, because we will be keeping track of the RAG document that has been loaded. Because if some user wants to introduce the same document twice, we will skip it and we don't duplicate it. So for every document in this list of documents that the user will be introducing, it will be uploading into the application. We check if it's already there. We check if we have more documents than 10, the ones allowed. And if that's the case, we'll be saving temporarily this file into the folder of the server just to load it, the content of it. Then we'll check the application type, and similarly as before, it's slightly different, but it's the same. And we'll be extending the docs list as before, and otherwise throwing a message to the user that something happened. And finally, as mentioned, we'll be removing this file that we temporarily uploaded. So whenever we load the content of the file, we will be deleting from the server for security and to not get too much data into it. So if there is any documents in this list of documents loaded, we'll be using this split and load docs that we'll be defining here now, this new function. So this will be the split and load function. So we'll be doing this at once. The splitter, as we saw before, and then the document chunks. And if vector.db is not yet created, we will creating it with this function. And if it's already there, we'll only adding the documents. This is something that we didn't see before, but if we already have a vector.db and the user is adding additional documents, we don't want to create from scratch a new vector.db. We only need to add these new documents to the previously existing one. So now we need to create this initialize vector.db, and let's define this function here in top of this one of here. Okay, so initialize vector.db, it needs the docs to initialize this vector.db. So we have from Chroma, from documents, docs, okay, using the OpenAI embeddings, and we'll call this collection name, this new as well. So as we can have multiple users creating different vector.dbs, every new vector.db will have an ID, a different ID. And for this, we'll be using the time function with some decimals, but we will be replacing the dot. And also the st session state. So it will be quite complex ID. So with all of this, we'll be calling this collection name. And if we have multiple collections from different users, we'll only keep the last 20. We'll see later how to do this. But like this, whenever we create new collections, new vector.dbs for different users, we will only keep the latest 20. So like this, our memory won't overflow as well. If we have hundreds of users creating vector.dbs, these vector.dbs will be kept in memory. So in order to don't have much of them, we'll be only keeping the last 20. So whenever we create a new vector.db for a user, we only keep the last 20. So we delete the older ones And like this, we keep the memory more or less matched. Let's see if the Streamlit Cloud can support this. But I think that having 20 vector DBs with up to 10 documents, this is something manageable. If you have your custom application and you have more memory and you need larger numbers, like more than 10 documents or more than 20 vector DBs, you can increase these numbers. But for now, I will be keeping these numbers of here. Okay, so now whenever we upload a new document, we split and load these documents to the vector DB. And if it's not yet initialized, we initialize it with this method of here. What we are missing is to create the load function for the URLs for the websites, as we saw before. So here in the bottom of the normal documents, I will create this load URL to DB, similarly as before. And we'll create now the widget in the website to load also URLs. But similarly as before, this URL of here, we are using web-based loader to extract the text, extend the docs with the text that the loader is getting, and appending these RAG sources to know how many RAG sources we already loaded. And if it works, we'll be using again split and load docs. So we'll be using the same to load this web content to the vector DB. So these 4 functions are the indexing phase, and now we need the retrieval and augmented generation phase. And here, as we saw before, we need the retrieval function that goes to the vector store and gets the more relevant chunks of documents. And then the chain that queries the LLM with the context input and all the history messages so it received in stream, the response from the LLM. And finally, we need this other function that we also saw before, that is using these 2 functions of here to finally put all together. So we create the conversation RAG chain and we introduce this RAG response to know better when a response has been generated using RAG or not. And here we have similarly as before that we generated the stream LLM response. So here we do it, but here instead of using the OpenAI chat or the Anthropic chat by themselves, we use the full chain, the LLM, but also all the retrieval augmented generation chains. And we generate all this response with the messages and this input that will be used here in the prompt templates. And the response of it's streamed in chunks as we saw before. So we are yielding this chunk to be displayed, but at the end, we get the full response message here in the session state messages history. Okay, so these are all the RAG methods that we need for our application. So let's go back to app.py. And now here we need to import everything. So let's do it in different lines. We need load doc to DB, load URL to DB, the stream LLM response, and the stream LLM RAG response. If we don't have any document or we don't want to use RAG, we'll use the normal LLM response. Okay, so we import these 4 methods that we define in the RAG method.py. And now we have to introduce some more things to our application to use RAG. So we'll start by adding here an option if we want to use or not RAG. So it will be optional. So here after calls 0, we'll add this. So this is a button. Let's see it. Here now it's deactivated because we don't have any document loaded, but this will allow the user to use or not the RAG chain. So it will be disabled as now if we don't have any vector DB here in the session state. And now here in the sidebar, let's put here a header of RAG sources and we'll create 2 methods. One to upload files with file uploader and we'll allow PDF, TXT, docx, doc, JSON not really, and PPT also not. So for now, only PDF, TXT, docx, doc also not. And Markdown. The other ones, there are some methods to upload them, but are not as much common and simple. So let's only keep this for now. We'll accept multiple files because we can handle a list of multiple files. And on change, whenever there is a new file, we'll run the load doc to DB that we describe in RAG methods. And very similarly, using text input, we'll be uploading URLs. And using the load URL to DB, here we can only upload 1 URL at a time, not multiple, but the user can add one by one the URLs that they want to introduce here. With the load URL to DB, we'll be loading them. And here we can tell how many documents are in the DB, in the vector data store. And we'll be checking this from the vector DB, get the metadata. So how many metadata are there, we'll know how many documents we have in the vector DB. And we need also to add here we were so far doing only stream LLM response, but now if we have here the use RAG, so if this is true, as we declared before, because we have a vector DB and so on, so if we are using RAG, it's activated by the user, we will use this up here. So if it's false, we will use the normal LLM response, But if it's true, the use RAG will use the stream LLM RAG response that we declare in this file of here. And I also need to add here this line of here, okay? I forgot to tell that this need because we are creating here this file path in these source files, but by default we didn't create this folder and it won't be created in the server, these source files. Here is where the source files are temporarily created. We need to create this OS make dir, so create this source files folder if it doesn't exist, otherwise it will not do it again. So yeah, we need to add in the rag methods.py in the load doc to db, we need to add this line of here to make it work. This was also something that was missing as well. Okay, these are all the changes. Now we can test the website. Okay, so now we have here these two components to upload files but also URLs. Let's start this again and now let's load the Word document here for testing. And it's here successfully loaded. It says the toast message. So let's ask what is my favorite food. That in the document said that it was margarita pizza. Okay, it knows. And how many bottles are there in the track? Okay, so there are 47,588 bottles. That was the content of that document. You remember the content of those documents was this. So yeah, it's properly getting it. Let's test now this URL again. So let's upload here now a URL. And as you will see, it's not creating a new vector DB, but it's uploading it. And I'm not sure what okay, these are the chunks. It's creating different chunks of the same website, but yeah, it loaded them here. So what is the latest version of Streamlit? The 1.38 as we saw before. So yeah, that's good. That's the latest one. We see that 138, but the previous ones were 137 and so on. So it gets good, and we can ask about what are the changes and so on because it's in there in the context. Okay, so it's working. And also another change I will do here, as we saw, we are listing not all the documents but the chunks of the documents. So we should have here only 2 documents and the website was split in 14 chunks. So we see like this. We'll change this. Instead of telling here from the vector DB to get the metadata, we'll get the RAG sources. This should work as well. This is the list of the file names, and also here, also this is not meta now. This is source and source. This will be the source file name. Now, okay, now it's better here. If we see, now we have 2 documents in the DB, the doc file that I uploaded before and the website. So we don't see here like every single chunk that we had many of them. Okay, now it's good. So now let's see how to paste this code to the GitHub repository and how to deploy this website to the Streamlit cloud for free. And in the next video, remember that we will see how to deploy this website to Azure. But for now, let's see how to do it in Streamlit cloud. So let's go to GitHub. Let's create here a repo. Make sure to create a GitHub account if you don't have it yet. So new repository, and I will create it as before, RAG LLM app, public. Okay, create the repo. And here you can see the instructions for pushing an existing repository from the command line. But first we need to create the repo. So let's stop the website and let's do git init -v main. Now another thing that we need to do is pip freeze requirements.txt file. So we need to tell what are the dependencies, and remember to have virtual environment activated before doing this. And we will be creating here the requirements.txt file with all the libraries that we just installed. And now we can git add all the changes, git commit, RAG app completed. And now we can follow the steps that GitHub was telling us. So git remote add. And git push origin main. Okay. Now, if we go back to the repo in GitHub and we refresh, we see here all the content. Okay, so it worked. But I had to do some fixes in the code to make it run in Streamlit Cloud. So it was working locally in our computer, but in the Streamlit Cloud, I had to do some changes. So first of all, in the app.py code, we need to add these 3 lines of here because the SQLite version in the Streamlit Cloud is not compatible with the ChromaDB. So we have to add these 3 lines of code here. We also need to add this line here in the role users. So in the messages, we were starting it with this role assistant and so on. But we need to add a new one. So the conversation needs to start with the user for Anthropic. So Claude was throwing an error. So this is another change that we have to do. And the last thing that we have to change is in the requirements txt. So first we need to add here this line, the PySQLite3 binary in the requirements txt. And if you're in Windows, as it's my case, if you have PyWin32 here as a requirement, you have to delete or comment it, okay? That was throwing also an error in the Streamlit cloud. So apply these changes, Control S, okay? Also the changes that I mentioned here. Here we need also to add the API key. So API key is the st session state OpenAI API key because we had it locally in our environment variables, but in the cloud we don't have the API keys in the environment variables, so we have to call it like this. And in the same way, we also need to go here when we ask the API key to the user. Okay, here OpenAI API key is the text input, so we have to put here key, OpenAI API key, so now it's in the session state, and also for Anthropic API key. So we need to do this, and when we go here and we create the LLM stream, we need to tell that the API key is the OpenAI API key from the session state or the variable name, and here as well for chat Anthropic, we need to create API key equals to Anthropic API key. Okay. These changes are needed in order to make it work in the cloud. Okay, sorry for that. It's correct in the GitHub repo and the blog. So now if we push these changes, okay, git add, git commit, and we can call it fixes, and we do git push. Now we'll have everything okay in the GitHub repo. And now with these changes in the GitHub repo, so now we have to go to streamlit.io and here sign up. If you don't have an account, you can do it with a GitHub account or with Google, but the GitHub account will be need to link. So I will sign in because I already have an account, and here we need to create an app. Yeah, I have an app. So you can paste here the name of the repository. The branch has to be main. Here the main file path is app.py, okay, is how we call it. And here you can call the app with the subdomain as you want. I call it like RAG LLM app, but you can call it however you want. It's not available because I already created before. So I already have this app created with RAG LLM app. And here one thing that I did just in case is I'm using Python 3.11 in my computer. So in 3.12 probably it will work, but just in case I selected here Python 3.11. And yeah, save, and now we could deploy this. I already did before, so we can check the deployed website. So now in this subdomain that we created, RAG LLM app.streamlit.app, here you can see it's working. Here, if you are the owner of this website and you are logged in Streamlit, you will see here manage app, only the user. And here you can debug, you can see all the logs that are happening in the server. So if you have any error, as I was having before with SQLite, you will see it here better, and you can also reboot the app if it's needed, if it's not rebooting itself. But now it's working apparently, so I can put now my OpenAI API key here to test it because I don't have it in the server. Enter and it's loading, so I can say hello again. Okay, it's working, and I can add the test file, for example, successfully loaded, nice. And I can ask, what is my favorite food? And it's getting margarita pizza from the RAG file. Let's check if the URL loader is working as well, the RAG from URLs. So let's add this here. And okay, it's appending in the previous vector DB. And let's ask, what is the latest version from Streamlit? And it's working again. Nice. So it's working. So let's leave it here. I hope you enjoyed and learned about this. Leave any comment or suggestion if you have in the comments. And see you in the next video where we'll be learning how to upload, so how to deploy this website in Azure with single sign-on and more advanced concepts. So make sure to subscribe and see you in the next video. Bye bye.